Welcome to my lecture, The Baltic Sea, Commercial Mussel Farming. My name is Lukas Ritzenhofen and I'm a scientist in the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research, Warnemünde, Germany, and the Marine Research Institute of University Klaipeda, Lithuania. Within the short video lecture, I will give you an overview about mussel cultivation worldwide and in the EU. We will talk about the motivation to practice mussel cultivation in the Baltic Sea. We will talk about the aquaculture candidate, the blue mussel, and how the longline system is constructed. We will also talk about the challenges that we face in the Baltic Sea regarding mussel cultivation, and at the end, we will have a short summary. Let's begin with what is aquaculture in the first place. Aquaculture is the controlled process of cultivating aquatic organisms for human consumption or other purposes. And the aquaculture sector is the fastest growing food supply sector in the world, and it helps us to sustain food security while the fisheries are stagnating. Currently, aquaculture accounts for 46% of the total fish production. Now let's take a look how the worldwide mussel aquaculture production looks like. Besides inland aquaculture and algae production, the mussel cultivation production is the third biggest production in production sector. Mussel production is an important economic food resource worldwide because mussels are a healthy source of proteins and rich on essential vitamins like vitamin A or D. Worldwide production amounts currently to 17.7 million tons. However, in the EU, the picture looks different. Here, the main producers are Spain, Italy, France, and the Netherlands, mostly cultivating in the Mediterranean Sea and the Atlantic Ocean. However, in the last years here, the mussel cultivation stagnated. There are several reasons for that. For example, frequent diseases in mussels, harmful algae blooms during the summer, missing mussel spat, so missing new young mussels, so that we have a problem in reproduction. We have predation by other animals like seabirds or starfish, for example, and low prices and low earnings, which makes it very difficult for small companies to survive. So why do we want now to practice mussel farming in the Baltic Sea? The reasons are that the former EU Blue Growth Strategy and now the current EU Green Deal, which promotes sustainable blue economy, gave new incentives for sustainable mussel aquaculture in the Baltic Sea. Because as you can see on the figure, if you cultivate mussels, you can improve the water quality of the marine environment because the mussels are filter feeders. They filter or they feed on the phytoplankton in the water column. And as they grow, they store nutrients like nitrogen and phosphorus in their body. Now, if the mussels are harvested, they are taken out of the marine environment and are brought back to land where the nutrients which caused the algae blooms came from in the first place. And mussel farming therefore has the potential to contribute to a sustainable blue growth in the Baltic Sea. However, the Baltic Sea is not the optimal place for mussel cultivation because we have the salinity, which is a limiting factor for blue mussels. As you can see on the left figure, we have there the Baltic Sea and the salinity gradient. As you can see, the salinity level ranges from 25 PSU at the entrance of the Baltic Sea to up to 2 PSU at the northeastern parts. However, the blue mussels occurs in most parts of the Baltic Sea, but in different sizes. And this is because it has to adapt to the different salinity levels. And it does so it takes energy, body energy, and to regulate the osmotic stress, which is induced by the decreasing salinity level, and this energy is then missing for growth. So basically, small-sized mussels can adapt to salinity, but they cannot grow as much as at full marine conditions. As already said, the best aquaculture candidate for the Baltic Sea is the blue mussel, Mytilus spp. The Mytilus, or the blue mussel, is already commercially fished worldwide, 1.2 million tons per year. And it's a filter feeder, like almost all mussels, but it has the benefit that it attaches themselves with buccal threads to hard substrate. This can be artificial or natural, but this is quite important because this enables us that we can cultivate the mussels in the water column. Another advantage is that mussel larvae are planktonic, so they're distributed by currents. So that means that you only have to put any kind of hard substrate into the water, and the mussel will attach itself, or the mussel larvae will drift by and then attach itself with its buccal thread and then grow. So you don't have to put the mussels in yourself. And this is how classical longline mussel cultivation setup looks like. It is fairly simple. It consists of 4 components. We have the mooring, which secures the farm. This can be a dead weight or a screw anchor. We have the long line, which is the backbone of the farm, where the collector material is fastened. And on the collector material, this is the artificial hard substrate where the mussel will settle and then later grow. And last but not least, we have the buoys, which are important for the flotation so that the whole system stays in the water column and does not sink to the ground. So far, there is only one commercial mussel farm in the German Baltic Sea, and this is a mussel farm in the Kiel Fjord. It's a small-scale farm. The farm is only 1 hectare big, and in the Kiel Fjord, the prevailing salinity level is 15 to 70 PSU. The mussels grow there 5 to 6 centimeter big, which is big enough for human consumption. The annual production are 5 tons, and this small business can only be economically feasible because it relies on an organic certified product. So the mussels are organic certified, and it only sells the mussels on a local basis. So we have a local marketing and an organic certified product. And therefore, this small scale business can take 11 euros per kilo, and this makes the mussel cultivation there economic viable. So small-scale mussel farming can be economic feasible, but only if you have salinity levels above 10 PSU and if you use a local marketing and if you can certify your product as organic. In order to investigate if the cultivation of blue mussel also works at lower salinities, we established a pilot longline mussel farm in the Greifswalder Bodden in 2018. And the Greifswalder Bodden is the biggest lagoon in the German Baltic Sea coast. The salinity ranges from 6 to 7 PSU. And tourism and coastal fisheries play an important role at the Greifswalder Bodden. However, also high nutrient input from industrialization and agriculture led to heavy eutrophication, and climate change is threatening coastal herring fisheries. So the idea is to test if mussel cultivation, mussel farming can there be viable, and if local mussel farming and sales could generate additional income for fishers and also remove nutrients. These were the results we obtained, the growth results. So blue mussels cultivated in the Greifswalder Bodden at salinities between 6 and 7 PSU reached a length from 1.5 to 2 centimeters. So we definitely have small-sized mussels, which we cannot use for human consumption, or which are not attractive for human consumption. And if we look at the weights, we can see that also we have, after 1 year, we had a wet weight, so a mussel weight of 0.8 grams, which is also quite light. So a 1 hectare farm could produce 3.7 tons of small-sized mussels within a year, which means that you cannot only rely on animal feed as a market, but you also need to use this mussel farm for nutrient mitigation to get kind of nutrient compensation. And here we found that also longline mussel farm benefits the mussels and the nutrient mitigation potential because, as you can see on the graph, the double L stands for longline, that mussels cultivated on longlines have higher nutrient content, phosphorus and nitrogen, both than mussels cultivated at the bottom. So, in conclusion, mussels cultivated on longlines can maximize the nutrient mitigation potential and increase additional income through nutrient compensation. What we also found is that if you harvest the mussels during autumn, you also have the highest mitigation potential and the highest nutrient removal. Now we come to the challenges that we face in the Baltic Sea. And first we start with high water temperatures during the summer. This are also results from our pilot farm in the Greifswalder Bodden. And as you can see, in 2018 in the summer, we had a decrease in mussel density on the collector material, which was due to high water temperatures. The water temperatures at this time exceeded 20 degrees. And as a result, we lost about 80% of our mussel stock. So high water temperatures in coastal waters can increase the mortality. Also relevant for spring and summer are high chlorophyll A concentration, which indicate algae blooms or cyanobacteria blooms. And we found that if you have high chlorophyll A concentrations, the filtration rate reduces. And you can also see that in this figure. There we have, for one's laboratory measurements and measurements at the mussel farm itself. And with increasing chlorophyll A concentrations, the clearance rate, so the filtration capacity of the mussel, also decreased. And in conclusion, that means that if you have strong algae blooms during spring and frequent cyanobacteria blooms during summer, this can also hamper the mussel growth and subsequently the mussel health. We do not only face challenges in the summer, but also in the winter. Especially in the inner coastal waters, we have frequent winter ice or annual winter ice, which can damage the farm. So here we need to submerge the farm. So from November till April, we submerge the farm beneath the water surface with additional weights to protect the farm from ice damage. This is necessary and costs also additional working steps. However, this might change in the future due to the climate change because, as we already can see here in this figure from the HELCOM report, is that with the ongoing climate change, the number of ice days are decreasing. So in conclusion, higher temperatures can extend the cultivation season, because we do not have to submerge the farm anymore because the risk of ice damage is gone. And as already said, at low salinities, we can only produce small-sized mussels. And as of today, there is not really a market for small-sized mussels. So there is also the challenge to find new markets. For example, for animal feed, there are a lot of trials ongoing to use it as a supplement for aquaculture feed or for chicken fodder. The shells can be used, for example, in agriculture as a lime substitute, or you can also potentially use the mussels as an energy resource, for example, for biogas production. Last but not least, we have the economic feasibility of small-sized mussel cultivation. Our studies showed that right now, even if we increase the production for small-sized mussels, if we use them for animal feed, we will never reach a cost-neutral point. Even though we also add compensation through nutrient mitigation, we will never reach the cost-neutral or the cost break-even point. That means that as of today, mussel cultivation at lower salinities is still not economic feasible. And also, if we increase the mussel production, we also increase the environmental risk that come with mussel cultivation. Now we'll have a short summary. So worldwide, mussel cultivation plays an important economic role and is a major seafood producer. However, in the Baltic Sea, it is only possible for human consumption if you cultivate mussels above 10 PSU and if you use a local market and if you are able to have an organic certified product. At decreasing salinity levels beneath 10 PSU, right now it is not economic feasible to cultivate mussels, even if you add the compensation by nutrient mitigation. So as of today, only commercial mussel farming in the Baltic Sea is possible above 10 PSU. I hope I could give you some interesting information about commercial mussel farming in the Baltic Sea, and thank you for your attention.